Okay, there we go. It just hit live.
Okay.
Let me see. I don't think so. I think the more I went through it, the more I understood it.
Okay.
At first, when I was watching the videos, because I kind of went through it without reading it, I was like, what? And then the more you go through it, the more it makes sense. And then I did the homework, and I think I got like a B on the homework, so that was not too shabby.
Okay, so like I think I get it. And then like I'll get a problem and I'll get one right, and then I'll go to a different problem and get it wrong.
Okay.
So there's something that I'm missing, and maybe you can, and I don't know, like on the homework I did everything right on there.
Right.
So
I think like some of the times, like when you get to the conclusion, like I think I was having a little bit of issues of explaining why are some of them are like state the null and the alternative hypothesis. And so I would put, like, for instance, I guess you haven't done in the homework yet, but it'll say like 135 bushels per acre or 133.1 bushels per acre. And when you're doing the null and the alternative, I'll pick one number and that you're trying to prove, and it's wrong for some reason. I did that once or something. But let's just go through it and we'll see.
Okay.
If I understand it now or not. Okay. Let me open it up here. I'm so excited to get this all done.
Yeah. This is nice. And I feel bad that Brianna didn't stay.
I do too. I can't believe, like, if it's a month, right? Like, if I already put a month in and was pulling, she had to have been pulling a C at least. I mean, we've been doing really well on all our stuff. So I've still got a high A in there.
Well, the only thing I can figure is if her homework stuff wasn't going well. Because as soon as I always do the homework right after our group meetings. And I always do really well on them.
Right.
For the most part.
Yeah, well, and I haven't gotten below a B on any of them. So
I haven't either.
So I just feel bad too, because she needed it as a prereq to get into.
I know.
So
maybe she was like, if I can't even get the prereq done.
Yeah.
But anyways, okay. Well, I'm gonna go ahead and start the quiz or the.
Yeah, sounds good. Me too. Okay.
Okay, so the status quo would be the null, right?
Yeah. Which hypothesis involves equality?
That would be. Ooh.
I don't know. That seems tricky to me. Let me open up the.
Okay.
The actual reading of it, don't you think?
Yeah. Okay, so I would think it would be the true hypothesis.
Which would be the null again, though, right? Did I lose you?
Yeah, I didn't hear you.
That would, if we're looking for the true hypothesis, though, that would still be the null.
So the null is what we're going to put, or we're going to put true?
We would what? Okay, the true hypothesis?
Mm-hmm.
Okay. Let's see. Open up that wiki so that we can.
Yeah.
Okay, when computing, let's see, the p-value is the probability of obtaining a sample statistic at least as extreme as the one. Uses information for question 5. When computing the probability, which hypothesis do you assume to be true? The null, right?
Okay.
Because you're always, that's why the null is the status quo. You're assuming.
Okay. Okay.
Right?
So we're going to put the null on this one.
Right. And I'm still I'm checking for that other one.
Okay.
Come on. Sorry, Mike. Okay, so it might be the alternative for that. Oh my gosh. I hate this thing.
Which one are you looking at, number 4 or 5?
I'm looking at number 4.
Okay.
Because involves equality is throwing me off a little bit.
Yeah.
Because I think it's null again. Because it has to be true. It has to be exactly equal to. Do you know what I mean?
Okay, hold on. Notice that the null hypothesis is expressed with a statement involving equality.
Yeah.
Ta-da! It's the null.
So it's null. Okay, that's what I was thinking.
Okay, and then...
Sorry.
That's all right.
Number
no, that's good.
Which of the following represents the alternative hypothesis for a two-tailed test? So okay, I have that in my notes.
Not equal value, right?
Right.
So the C?
Uh-huh. Which of the following represents the alternative hypothesis for a left-tailed test, which should be...
Would be less than.
Right.
So A. Right?
Well, my less than pointing towards the mu?
Yeah. So mu is less than 10.
So I guess it's... Is your open face, your alligator face, like they teach you in school, facing the mu, or the 10?
No, it's going to eat the 10.
Okay. All right.
Okay. And then right-tailed twist, it's going to eat the mu.
Okay.
Right? Okay.
Yep. Sorry.
I love it. I remember alligators when we had to make them with our hands.
I know, but that's the way you know, greater than less than, but it's just on my notes. It's just, it just tells me one-sided. So I need to go back through and read about the tail. How did you know about the tail?
I just have it written down.
Okay.
So I have equal versus less than one-sided, and then I had written down mu is less than value.
Okay.
So I just had it so I can see it, like I'm looking at which way the tail faces.
Okay.
Okay. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance.
Sigma.
Failing or reject. So when you reject, the p-value is smaller than alpha, right?
P is low. Reject the null.
So in this case, the alligator is going to eat the alpha.
Right.
Okay.
Oh, wait, failing to reject.
No. So this is accepting. So opposite.
Right. And then 10 should be eating the alpha.
Okay.
See, and all those words just trip you up.
I know.
The insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim 1,500. They are concerned that the true mean is actually higher than this.
So it would be...
It's greater than.
So,
right?
Yeah. The average claim amount is greater than 50. So C?
Uh-huh. That's what I put.
Okay. And then
which of the following would be the appropriate null hypothesis? The average claim amount is equal to 1,500.
So A.
Right.
Okay.
Okay, so then we just do the Z-score thing, right?
So how do you know if the sample mean is normal?
Well, you know what? We know just because the sample is more than 30. It's another trick.
Oh.
I'm sitting here ready to do all these calculations, and it's just yes.
Okay. And I have that written down. Sample size is greater than 30. Okay.
What theorem or law justifies your answer? Why don't they just tell us? I hate that they keep on asking us this one.
Well, and I wrote down sample size has to be greater than 30, but I didn't write down what law that is. I think it would be the
law right now. Hold on. I'm finding it. It's just on my review. Where are you? Okay. The distribution of sample means is normal when X is normally distributed, or when, thanks to the central limit theorem, our sample size is large.
What one is that?
So that's the central limit theorem, but let me read you, okay. The insurance company assumes, just because it's, okay, and then because the law of large numbers states that the sample size gets larger, the sample mean will get closer to the population mean.
Hey, did we read anything about the law of total probability? Nope.
No. So I think it's still just between these two. The sample means, I think it's the central limit theorem, because the only reason why we decided that is because our sample is larger than 30. And that's because of the central limit theorem.
Okay, in the reading for the central limit theorem, we learned that bar X will follow a normal distribution if the data are drawn from a normal distribution or if the sample size is large. You just read that. Okay, so central limit theorem is what we decided, right?
Right, because the law of large numbers just means that everything will get closer to the population if it gets larger. So, you know, say we have a sample of like 29 and it's pretty close, but we're not sure. As soon as we up it to a sample of 100, then we're going to know that they're all going to be closer in together for the law of large numbers.
Right. Okay. All right, 15. So the Z-score is the test statistic, right?
I think so. Okay.
Is that right?
No. See, I've got to make sure that I scan through all this before.
So I put test statistic equals, and then that whole formula to find the Z-score.
Okay, then yeah, that must, because that's what we're solving for.
Right.
All right. Okay.
So okay. What is the Z-score?
Okay, so 144 minus 150 over 40.
Over 40?
Oh, what's our standard deviation of 40?
Yeah, we have to divide that by the sample size.
What's the sample size though? 36. Sorry, did not read that all the way through. Thank you.
Oh, it is right there. Sample of 36. So divided by 40 divided by the square root of 36, right?
Yep. Get negative 0.9. 01.
Yeah, 0.9. Where did you get 01?
Hold on, let me redo it.
I get 0.900000000.
Okay.
So
negative 6 divided by 6.6666. Okay, negative. What did you get?
I got negative 0.90000.
Okay. Yep.
Okay, and then we have to put this into the applet, right? To get the p-value.
Oh, you're going down. I'm like, I thought we were done.
Yeah.
Yeah.
Okay. And then what are we looking for?
Okay. So she will use significance.
So decrease.
So below.
So we do the left side, right?
Do we do the whole left side or just the last left side?
Just the last.
Last, yeah.
So 0.1841.
Right.
Okay.
What inference would you make about the null hypothesis? So we've got.
If the p-value is, what's A?
P is low, reject the null. If it's greater, we fail to reject. So we need to fail to reject, right? Because it's almost triple the size.
Right. So, but mine says do not reject. If the p-value is greater than A, which it is,
we fail to reject. So because they always put reject the null or fail to reject the null.
Right.
So if it's greater, we fail to reject.
Right. Okay, and then type 1. So you're rejecting the null when the null is true.
Type 2 is high, so it's type 2.
No, I put type 1. This says, okay, reject the null when the null is true. And I put type 1.
There are 2 types of errors that can be made when forming a hypothesis. Which one involves rejecting the null? When the null hypothesis is true. It's all this.
I know.
When it's true. Okay, you're right. I'm looking at that chart. Because if the result is true and we reject the null, you would do a type 1 error.
Yeah, that's what I have written.
Oh my gosh. Okay, see, that's where it gets super confusing to me.
Ooh, this one's hard.
A researcher decided that instead of using a level of significance of 0.05, he will use 0.01, which will be true. Okay, so what I have highlighted here when it's low like that, you have a type 1 error. But will that increase?
Ooh. Ooh.
Because I'm looking at part 2, number 1. If we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? So I have here highlighted 2. Type 1 is low. Type 2 is high. So we have to increase level of significance to increase it, because we wanted it to decrease.
So the probability of a type 1 error will increase?
Right, because we went down.
Right.
We so decrease.
You have type 1 is low.
Right.
And type 2 is high.
Right.
We went lower, so we are increasing the probability of type 1.
Okay. Sounds right.
Ew, I don't like this one either. Compute the probability of committing a type 1 error?
Wouldn't it just be 0.5?
How do you know? How'd you get that?
Because that sigma represents 5%. So it should be 0.05, don't you think? Or am I making that really simple?
Yeah, that's right.
That's all the
probability. I have written down probability of type 1 error equals alpha. So it is 0.05. What?
I think so, but there's no other there's no other formula or anything that we did that for, right?
Yeah, I think that's right. Oh my gosh, are we done?
We're done.
Oh, are you submitting it?
Okay, I'll submit.
I'll do it.
If we do awful, I'm sorry. We'll know we need a little more.
Oh, we did good.
Oh, awesome.
Did you get a 95 too, or did I type something wrong?
No, I got a 95.
Okay, so that 20 is the one that we got wrong. So we'll have to fix that one. That's okay. That was awesome.
So maybe it's the other way. Because we decreased, then we did. It's all in that wording. Because if you decrease, then the type 2 increases. So instead of a 5, we went down to a 1.
This is like trying to understand a sentence with like 5 double negatives in it.
Yeah, seriously. That's what I feel like too.
Yeah.
So, I don't know. Sometimes I think, well, it's like 1 point. If I don't, I get the gist of it, hopefully. So that's good. I think that was great for finishing it today. And all right, cool. Good luck on your test. I'm going to take it right now and be done with everything.
Yeah, good luck to you. Okay, see ya.
Thanks. Bye.